Hello everyone, I am an avatar created by Yili Lin, a doctoral student in Health Services Research at the Department of Health Administration and Policy, George Mason University. Today, I'll be introducing you to addressing missing values in R. Missing values occur when data points are absent from a dataset, either because they were not collected, lost, or unavailable during data collection. In R, missing values are represented by NA. Types of missing data: missing completely at random. The probability of a value being missing is unrelated to any observed or unobserved data. Missingness occurs purely by chance. Missing at random, the probability of missingness is related to observed data, but not the missing data itself. For example, older respondents are more likely to skip questions about technology use. Missing not at random, the missingness is related to the value that is missing. For example, people with higher incomes choose not to disclose their income. To determine if data is missing at random, create a binary variable indicating missing values. Set the variable to 1 when X is missing and 0 otherwise. This indicator helps assess whether missingness is related to outcome Y, guiding the choice between simple techniques like removal and complex methods like imputation. Regressing Y on the indicator X missing. If the missing values are significantly related to Y, then the data is likely not missing completely at random. Use summary model to get details on the relationship between X missing and Y. If the coefficient for missing X is significant, P is less than 0.05, it suggests that the missingness is related to outcome Y, indicating the data is not missing completely at random, and imputation should be considered. Conversely, if the coefficient is not significant, the missingness likely does not affect Y, suggesting the data may be missing completely at random, allowing for simpler methods like data removal. Basic functions to detect missing values in R, is.na, returns a logical vector of true for missing values and false otherwise. SUMISNA data counts the total number of missing values. Any NA data returns true if there are any missing values in the dataset. Remove rows with missing values if the missing data is small and missing completely at random, and if your analysis can tolerate a reduction in sample size. This method is easy to implement, but may lead to data loss and potential biases if the data is not missing completely at random. Replace missing values with the mean, median, or mode of the variable when data is missing at random. This method is simple and quick, but it can distort the distribution and relationships between variables. Use the mean function to calculate the mean or median, setting na_rm true to exclude NA values. Then, assign the mean to all missing entries in the data. For mode imputation, use the getMode function to find the most frequent value in a vector. Utilize unique to get unique values and tabulate to count occurrences. Use which.max to find the index of the highest count. Replace missing values. Substitute missing values with the calculated mode. Mode imputation is particularly effective for categorical variables and works well alongside other imputation methods. Multiple imputation using the multivariate imputation by chained equations mice package. This method creates multiple imputed datasets and combines them for analysis. Install and load the package. Use the mice function to perform the imputation. Number of imputed datasets to create, typically 5 to 10. Method, imputation method, such as PMM for predictive mean matching, norm for normal regression. You can specify different methods for different variables. Seed, random seed for reproducibility. The complete function retrieves one of the imputed datasets. When data is missing not at random, use the missing indicators method. This involves creating binary indicators coded as 1 for missing values and 0 for present values. Including these indicators in your analysis can enhance model fit by addressing the missing data mechanism, allowing for explicit testing of the relationship between missingness and the outcome variable. To replace missing values using predictive models, determine which variables have missing values and potential predictors. Choose a model based on the variable type, linear regression for continuous, logistic regression for binary. Use complete cases, rows without missing values, to train the model. Apply the trained model to predict and replace the missing values in the dataset. Always identify and explore missing values first. Use appropriate methods based on the type of missing data. Consider advanced methods like multiple imputation or missing indicators if necessary. Test if data is missing at random using binarization and regression.